So I will start my presentation with a few of the new features and improvements, and my colleagues will continue with the rest. The first important feature is our brand new OpenChecks platform. I will show you a live demonstration, and I will continue with mentioning a few improvements in steel design, in loads and combinations, in temp table input and results. And for the rest, there will be 2 additional presentations. Main improvements in version 14. These concern a wide range of functionalities and design features. The most prominent of these features is the Open Design Platform. So what is the Open Design Platform? This allows you to create your own user-defined design rules and link these with Scia Engineer. It is based on a bilateral link with our 2 Scia design forms, and we make sure that data that is once defined in Scia Engineer is reused as much as possible in your external calculations. Following that, I will present you some improvements in steel design, namely the speed and report have been improved for flexural buckling checks. Then I will show you some improvements in steel connection design for the Eurocode, a new setup, simplified bolt definition, a new error warning and note message system, design of moment connections with 4 bolts per row. This was available since version 13.1. I will only mention it for the ones who have missed it. And one of the components has been completely rewritten to provide a better report and improve the speed of the calculation. Further on, improvements in combinations. The updated version of the International Building Code from 2012 has been implemented. Also, the Eurocode seismic combinations now automatically include the 30% rule. In the 3D wind generator, we have now implemented the new IBC norm from 2012. In that the directional procedure is supported. The water accumulation module has been changed, so now the model factor for stiffness reduction is available. And new profiles and materials are available in our material and profile libraries. The table input functionality has been improved, and there's a brand new feature, table results, which allows you to view your results in table form. It also allows you to export to database management software and so on. The motto of our new release is expanding design. So what does this mean? We have selected this motto for a reason. Imagine that you are familiar with a design method that you have read in literature, or is published in a design norm that has not been implemented in Scia Engineer, and you can easily describe this method using a set of formulas and conditions. So far, I know that many of you do this in their everyday work. You use spreadsheets and other software that you find convenient. But the problem is how to get data from Scia Engineer in an automated way, so you don't have to retype values. And also when it comes to the visualization of your results and the reporting of these results, you are more or less on your own. But in our new version, 14, you are free to define your own calculation routines using a set of formulas and conditions, some useful descriptions, text, images, dynamic drawings, graphics, and you organize this into a neat report, and you can link it to Scia Engineer. As soon as you have linked it, we ensure that there's an automated transfer of model data, of analysis results, and that you can call your check via a single click, and then you may plot on the 3D structure. You may use our auto design feature, and you can also report your results, add them to the project documentation. And the bottom line is make sure of Scia's 3D visualization and reporting capabilities for your own calculation routines. The main benefit is that we let you expand the software that you use beyond what is shipped. And how to do that? You invest a limited effort to create whatever routines you would like to use, and we ensure that these routines will be handled in the same way in terms of graphical display, units, settings for units, warning and error messages, optimization, and reporting. A simple example in this slide, let's assume we have a 3D structure of a bridge, a model of a bridge, and we have, this is a very, very simple example, everyone can recognize it, a generic bending check, a section check for bending. From the notation you see it's written according to the Eurocode. It could be any norm, it could be an Australian norm or any norm that you need. Let's say that this is a check that you have written, and this check uses cross-section and material data from the Scia model, and also uses analysis results. It uses the bending moment, and the result of this check is of course the unity check value, and this one can be plotted onto the 3D structure. I will give you a live demonstration, a very simple example. I will continue the presentation with a small demonstration. I have made a model in advance where I can show you a very simple example on how you can include your own checks while designing your models. So this is a simple structure. It has steel and concrete cross sections. So here you see 4 different cross sections. I've also added the names of all of them, and the bottom ones are 2 concrete sections which are located to the lower right of the model. Of course, you have to perform all of the linear calculations before you can use open checks. So here you see the design forms service. It's a service which is specially dedicated to your own checks, and in the check manager you can arrange your own calculations. So let's see how everything can be set up in design forms. We will open the builder application from Scia Design Forms. As you see, I have prepared 2 examples for you. This one is a really simple one. So we have a simple code, and then normally the values for all of these for the variables are taken from libraries in Scia Engineer, or they can be introduced by the user using the dialog in the user application. But in this case we are going to link to Scia Engineer, so we do not need such a dialog. Here you see the internal model data of Scia Engineer. It can be read via this EMD loader, and there are particular strings that you can use to refer to these variables inside your model. So we save and we export, and what we see now at the moment, this form reads data from the model that is currently used in Scia Engineer. So we have the cross-section area, the normal force, the safety coefficient for material, the yield strength, and using these variables we calculate the unity check results. In this I/O viewer you see all of the variables, all of the model data stored into a tree structure, and you can easily find what you need using the I/O viewer. So at the moment the file is set up and all of the variables are correctly referred to. We define result variables, so these are the variables that will be considered in Scia Engineer as results. I selected the unity check, and just to demonstrate something, I also selected the cross-section area. These variables now appear in the header tab you can assign the correct unit per variable. So what does this mean? If you select the equivalent SI unit for a particular variable, this means that values for this variable will be plotted in Scia Engineer in the units that you have selected inside the settings of Scia Engineer. A couple of other settings are related to the applicability of the check. Is it going to be performed for Eurocode or for another norm, or will it apply to 1D members or to plates or to nodes? Also, to which member should it be applied in terms of materials? So a check usually is performed either for a steel or a timber member or a concrete member. So this can all be taken into account. And then we can export the CLC file into the correct folder. In this case, the file has already been placed in the OpenChecks folder of Scia Engineer. We read it in. We can select icons for, on one hand, the check itself. On the other hand, also there's another icon for additional data. Remember, we also select for which norms should this check be performed. It means if we are currently using another norm, then this check will not be visible. The same is valid for material and for the type of member. You can also see the output variables, settings, all of the settings related to the visualization of these. Also, you can activate auto design options. And now the check is read into Scia Engineer. We see here that it appears in the tree. It's a very simple check, and now we're going to see what the results are. So now, depending on the normal force in these steel columns and diagonals and beams, we obtain the result of the unity check. So the values appear in gray because for all members the values calculated for the check are below the 0.25 norm, and changing the load combination resulted in bigger normal forces. So now you see that the check results are higher. Still, all of the members fulfill this check. We can also use the preview. We have two types of previews. So the brief one, which gives you the results in table form. So here you see the unity check values for each member, and this is a maximum per member, so every member is checked in a number of sections, and also the area is plotted because we selected it as a result variable. The following type of output is the detailed output, and the detailed output gives you as a calculation report what you have formatted in Scia design forms. So you see that as it was shown in design forms, now it also appears. Here you see the area, the normal force to the right. We can also add some additional information. So let's add some text to indicate what is the name of this member for which the check is currently listed. So the member name, here we see it in the tree. So we know where to look in the tree structure. There's also IntelliSense to guide you through the process. And now we obtain a small label which says these results are for member B13. So let's reread this, so re-import this check in Scia Engineer. Yes, and we can perform the check again and print the detailed output, and in this case detailed output will also show us for which member we're doing the check. So we check that all of the properties are correct. We perform, for example, for each cross section, and then we show the detailed output. The calculation is being performed, and now we can look at the preview. So as you see, these are the extremes per cross section. So for example, B2 is the highest force for the corresponding cross section. Another thing I wanted to demonstrate, just as a proof of concept, let's print the area values. So in this case, the area is set up as a result variable, and now these the values are plotted onto the members. Another thing we will display is the name of the cross section. And why is that important? That way we can compare with the plotted results. So in this case, you see, for this member, this column, we have an area of 5,380, and the result, which is shown by the check, so the area as taken from the design forms calculation, is also given. Yes, it's the same value here for the diagonal, and now we have this roof beam, and in this case it's 2,710 for both in the check and in the name of the cross section. I retyped the area and added it to the name of the cross section for this comparison. Again, plotting the unity check. For another reason, I will demonstrate the auto-design feature. So the auto-design feature works identically to how it works for in-house checks. It means for each cross-section, it is possible to cycle through the Scia Engineer library to find a more optimal, more used or better suited cross-section for the member, depending on certain check that is used as criteria. So in this case, first we do for the columns, we have to reduce the cross section, of course. Remember, this is just a tensile check, the results are not very realistic, it's just a demonstration. So now we change the cross section of the columns, then we also will change the floor beams. Okay, so search for optimum. It means the cross section now is going to be selected from the library of HEA profiles. The original is HEA 200, and most likely a smaller section will be selected. Currently HEA 100 is suitable. The same for the diagonals. The forces in them are very small, as you can see the value of the unity check. The system searches for a better solution, and most likely we will be using the smallest profile. Yes. So now these are the updated unity check values. Of course, the structure needs to be recalculated so that the results will be precise now with the updated cross sections. Nevertheless, if we continue like this, we will get a message in the report that the results are not valid because the structure has to be recalculated. So here you see at the top the structure has to be recalculated, so this is okay. But just to demonstrate, I will again show you the improved check results. So again, for the ULS combination, now we have unity check values that are closer to 1. So this is an improvement. There's a second example that I've already included here. The second example is a generic bending test. And I will print these results also. So for each member, we want the unity check values plotted. Let us check the member data features. What are member data? So if we look at the example that I'm currently showing in Scia Engineer, on the dialog tab, you see that I have prepared a member data. This is entirely for linking with Scia Engineer. It's the values that cannot be retrieved from Scia Engineer or from the model, need to be manually introduced by the user. Here it's the safety factor, of course, can be obtained from Scia Engineer, but just as a demonstration. So I will perform the same check, but now with a different safety factor. Let's try these columns. Will be assigned a safety factor of 2.5, so now it will be obvious when the results are plotted that different values should be obtained for these columns. Labels are shown, and when you click on the label you can review the data that is defined for this member in particular. For all of the other members, the default values are used. So here you see the same check performed twice resulted in higher values for the unity check for these columns. Still the values are quite low, so you only see that only one value exceeds 0.25. And it is exactly for the columns which we designed with another safety factor. So, and last, I would like to show the engineering report, how it works with external checks. So here in the tree you see design forms and then the checks that you are currently using in this model. When you perform the regeneration, then you will see the plot of your results. So here you have the same options. You have to define for which members, for which selection of members do you show the results. Or you can have options related to which column should be visible. So in this case, let's improve a little bit the visual style for this one. Related to the first check we performed, it was the normal force. The normal force check had two result variables. It was the unity check and the cross-section area. So here you see I show the detailed output for the normal force check, and it appears depending on the options which are given in the properties window. And again, let's do this for the bending check. We will again we will also plot the detailed output for a number of cross sections, so extreme for each cross section. After regeneration, you can set up the options for the plotting of the design forms output. In this case, first iteration appears quite okay. Here there are options. You can remove the top table, and you can also add additional data if needed. Then the bending check, we can also show the brief layout. So let's show for the ULS combination, and we should obtain the results in table form. And voila, here is the check results for the two checks. Both brief and detailed output are added in this example. Also, it's possible to, for example, add the cross-section area. Now you have both result variables plotted in the table. So this was the demonstration. I hope you enjoyed it, and we will move on to the following presentations. Related to steel improvements, the speed of the calculation is improved and the output has been extended. I have provided a PDF where all of these improvements are explained in detail, and I will upload it together with today's webinar. The following improvements are related to the steel connection design. We have, first of all, the column webbing compression component has been rewritten. We have a new theoretical background for steel connections, and a new definition of bolts, a new dialog, plus new error messages. So the old horror of error messages, as you remember it from previous versions, has been replaced. So now all of the messages are listed in this window here. And also these messages are color-coded. So green means that all of the distances are within limits. Another improvement is that the setup of the previous versions has been rewritten and reorganized because it was rather messy and things were difficult to find. There's a new structure. We also have added additional parameters where needed, and all redundant content has been removed. Another improvement is that for each item here, there's a reference, description, and application strings added to explain the coefficient, where it comes from, what's it used for, what are its ranges, and so on. The same has been done for Eurocode 0 setup. Also, you see the reference, description, and application fields. The following improvement is related to the generation of combinations. Now we support the latest version of the International Building Code. So all of the changes in coefficients, different equations, and components have been taken into account. Related to temperature, because temperature was taken out of these equations, we looked at the commentary of the ASCE norm, and their equations were given for how to take into account the temperature loading. And the same is valid for the ASD combinations, so all of the coefficients and all changes in coefficients and components are taken into account, and additional equations for temperature are added. Another improvement related to the IBC 2012 and also the old version is that these coefficients F2 and F1 were implemented in the previous version, but they were very difficult to find, hidden behind artificial load types, and also I assume that one had to know how to define the proper load type to be able to take into account the correct coefficient. In the new version, there are settings for the function of the floor and for the roof configuration, so now it's more transparent and easier to define the two coefficients. Also, for both norms, the version of 2006 and 2012, we have automatic filtering of duplicate combinations, which improves the speeds. It also improves the speed of design calculations and also the review of results. And another feature is when you switch the codes, all of the generated existing combinations are automatically generated. The following improvement is the automatic 30% rule. So now the seismic combinations according to the Eurocode take into account the 30% rule as given in the Eurocode. In previous versions, you had to use active coefficients to create these coefficients yourself. but now this is done automatically by the software. Also including the new improvement of accidental eccentricity in seismic design. This also is assigned, accidental eccentricity load cases are also assigned the proper coefficients according to the 30% rule. For the users of the water accumulation module, as in previous versions, the procedure to define the pond loads on the structure is iterative because we have to know what the deformed structure is as a result of the water load. And in this version of the software, it's possible to define a coefficient which reduces the stiffness of the structure. We call it the model factor because that was the name used in the original implementation according to the Dutch norm. But now we have made this available for all norms. And then related to the 3D wind generator, the new version of the IBC norm has been implemented. The directional procedure is available. The user needs to do, let's say, a limited amount of work. All of the load cases are automatically generated. You can exclude certain load cases if you do not need them, and also it's important to notice that torsional load cases are also generated. And here you can override the internal under and over pressure coefficients. The setup for wind for the American norm is quite extensive. It has a lot of options related to the version of the norm, the basic wind speed, the risk category, the directionality factor, gust effect factor, exposure coefficient, and so on. New materials in the steel library are the materials included in all of these norms, and also we take into account the reduction of strength in function of the gauge. So as you see here, you can select any of the materials according to these norms, and automatically the values of yield strength and tensile strength are filled in automatically for a range of thicknesses. Table input, many of you know the table input feature. It allows you to define your model in table form. New features are the so-called filters. What are filters? So for example, you have, if we look here, we have a long list of members, and we want to localize some of these members. You can define here different strings on each column, so a number of criteria as filters, and it means every element, or in this case it's a member, that does not contain these strings will be filtered out. So that way you can select and localize different members in your model. The column selector, there are various improvements here. The drag and drop of a drop function now works. Also, you can simply remove columns by grabbing the header and dropping onto the table. Then all of the items that are available in table input can be seen by right-click, and then you see 3 groups of properties. And in this version, icons have been assigned to each property so that it's easy to locate what you're looking for. These icons are the same as in the main tree. And also, this is the list of new items that are available in table input. So, for example, you can define hinges via table input since this version. Trapezoidal loading is also, it's possible now to define it via table input. There's a direct link to the section library. So, for example, if I want to change a certain cross-section, I press on these 3 dots and the library for cross-sections is opened. And there are various functionalities related to smart copying of items. For example, if you have a node, you can copy it by relative coordinates 1, 2, and 3 meters, and these are automatically taken into account here for the new node. Table results, this is a brand new feature. It allows you to view many of the result items in Scia Engineer in table form. For example, internal forces, reactions, displacements, and so on. You also have filters here. They work in the same way as in table input. In fact, the two functionalities are quite similar. The difference here, a very important feature, is that you have separate refresh buttons for table results and for the graphical display. This means that you can be showing internal forces in this 3D window and list reactions in the table. The so-called result case is this string that is listed here. It shows you what is being displayed, for which load or combination, and for which selection of members. The column selector, it also has a drag and drop functionality, and other options include, for example, dragging a header onto the body of the table. Then you see this X appear, means that this column UZ will now be removed. So example of table results for displacements of nodes, and this is design of reinforcement for a concrete building. You can see that things have been arranged in multiple tabs. So this was the end of my presentation.
Good afternoon, everyone. I will show you some general improvements in the new version Scia Engineer 14.0. Let's have a look. Okay, so I will start with some new settings that you will get to see during installation of the new version. There you will be able to fill in your username and organization. If you would like, you can afterwards print it in the header of the engineering report. So this is some small item, and next to that, also during installation, you will be able to copy the user settings of a previous version of Scia Engineer. So you will get to see a list of all installed Scia Engineer versions on your PC, and you can select which settings you would like to reuse for version 14.0. What in fact will be copied is the content of the user folder, for instance containing templates of the engineering report, toolbar positions, etc. Also some registry settings will be copied, and the location of your project folder. When starting up Scia Engineer 14.0, you will also see a new project manager. So it will guide you through the list of existing projects. You will also be able to create, of course, a new project. You will get to see some sample files, including tutorials. And what is also quite interesting is you see here on this screenshot a list of recent projects, and while you browse through them you will get to see a print preview of the selected Scia Engineer model and also the project data. And at the left side, so here at the left side in the gray area, you will also find some useful links, for instance to the protection settings, to the web help, to our website, etc. Next, there are also some engineering reports improvements. One of the major requests by our customers was the introduction of templates, like we had in the old document as well. So to allow the user to create his own customized templates and to be able to reuse them later on in other projects. So you will be able not only to create your own templates. There is also a list of default templates that we have foreseen to get you started. A next improvement in the engineering report is the possibility to import standalone Scia design form calculations. So what Iveta was trying to show you during the demonstration was to give you the results of a linked design form to Scia Engineer. But next to that, it's also possible to import a standalone calculation, and I will quickly show you live later on. But first, the last improvement in the engineering report is speed and memory optimization. So quite some development time has been invested in that. So for instance, for indented tables and images, you will see that the regeneration of the content of the engineering report will be a lot faster than before. So I will go now to Scia Engineer and show you quickly these novelties in the engineering report. So here you see a prepared small steel frame structure. I have added loads and the calculation has already been done. So I will go immediately to the engineering report. So, okay. So a brand new report has been opened, and what you will find now in the list of new items is at the bottom a new option, report templates. So you will see here the user templates. I have prepared one, and I will load it into the navigator. And then you will see that in fact the layout and the content, so the structure of the content will be copied from as it was created in another project. I'll regenerate everything, so you can here in the taskbar at the right side see the progress, but okay, regenerate all outdated. I will switch the view to fit a window. Then you can get to see the overview. Yeah. Okay. So this is quite easy. As I told you in the PowerPoint presentation already, there also have been added some default templates or system templates. In fact, those are little snippets that you can use to compose your own new engineering report. So for instance, I will add the 0D reactions item. And this is in fact a block of some items related to reactions. So there's first an overview of the result classes, and then the tables with numerical results of the reactions, and also some images are indented below it. So if I regenerate this item, okay, so then you will get to see the results. In fact, you will see per result class the numerical results as well as the images. So now, suppose that you have created a new content, a new template content, then you can just go here to the button at the left top and choose for Save as Template. And then you can fill in a template name and even a description. So that's it regarding the templates. I'm sorry, this wasn't supposed to happen. Okay, there we are again. So what was a second novelty in the engineering report was the addition of standalone design form calculations. So you will find that here under special items design form. Okay, it has been added here at the top. And when I double click on it, or when I click on edit, the Scia Engineer, the Scia Design Forms user application will open. And you can here open any form, default or one that you created yourself, it doesn't matter. I'm going to the forms from the pile design package, and I will select here a few, for instance, point bearing pile, and a second one, geostatic stress. So you can in fact load as many forms as you want to this project. You can you can modify the input data in the dialog. So for instance here, what can I do? I can add dry units, so it's added on the picture. I can change the groundwater level from 5 to 4 meters, for instance. You see that it has changed here. All the input data and the report output will be saved. I can just close the application. And then everything, all the contents of the report will be loaded into the engineering report. Yeah, you see also the images are loaded here. By default, it's quite a large text font, but I can easily, in the properties menu, change the scale, for instance, to 0.8, regenerate, and then everything is up to date with a smaller text font. So that's it, I think, from my side. Then I will give the presenter to my colleague Gerda for the next item.
Hello, everybody who is attending this webinar. I will show you some other general improvement in Scia Engineer 14, which are mostly linked by the solver and results. And my motto is better understanding of your model. What we did as some novelty is a Singularity Check. What does it mean? Sometimes there is a problem with singularity in the structure. It's detected during the calculation. You can see these message boxes which are saying calculation aborted, singularity in the node, or the stiffness matrix is singular. And it's here not clear what does it mean. You cannot easily locate it in the model. What you can do with it, the question is if you can see the singular shape in our software. It means in Scia Engineer 13.1. Can you see the rigid body modes? It means the translation on or the rotation of the whole structure. Can you see the translation or the rotation of the part structure or some not connected members? The answer is very simple. You cannot. Therefore, we decided to develop something which helps you to work with a singularity in this case. So therefore, we implement the check of singularity. In the case that the solver says that structure is singular, you will see the message box with the note that it's possible that calculation failed by singularity of construction. Do you want to check? Do you want to run check singularity? You can click on yes. You will see the new window with the structure, and I will show you it on a video later on. So the answer on the question, yes, you can see the singular check in Scia Engineer 14. Here is the live demonstration of the singularity check. So I hope that it will work. So I model some structure, I run the linear calculation, and I can see the message box that the stiffness matrix is singular. So then the next message box, calculation aborted. Do you want to run check of singularity? Yes, I can, because I'm curious what is wrong. Now I see the animation window. I can run the animation and I will see the singular shape of the cross section. So I can see that the problem is maybe here on the edge. I can go to the back to the model, add the support, run the linear calculation once again. Still there is some problem. I would like to see what is wrong, and now I see that maybe the last part which is freely moving or rotate is this beam around this point. So what I can do, I can add the additional support to this point. Now I can run a linear calculation once again and see if it's successful or not. I can see that it's successful. So it was the short live demonstration of the Singularity Check. So I will continue with my presentation. The next improvement what was done was a so-called elastic mesh, which is something which can provide for you some hybrid mesh. It's a mix of rectangular and triangular elements. So the new mesh looks like is displayed on the picture. The next and the big improvement was done in the area of the working with the singularities and the problems with the peak values on 2D members. So there is some problems with singularities in the calculation. You can imagine when you support the slab with point support, or if you load the slab with point force, it can produce some local singularities. Then it can produce some peak values in internal forces. You are not able to properly design reinforcement on these cases. So there is also the question, what is the proper density of mesh? The standard and the most common solution in the previous versions of Scia Engineer, for example Scia Engineer 14.1, it was the manual mesh refinement. So when you would like to do the mesh refinement, you have to open this service. You have to choose from three items for the refinement. If you would like to refine the mesh in the node or along the edge or on the surface, for all these items, you have to know what you do. So for example, in the case of the node mesh refinement, you have to know some radius, some ratio, some coordinates. Then you have to select some type of mesh refinement. If it will be some linear increment or some equidistant. So you have to be some expert in this area to properly define all these needed variables. Then you will see this very nice picture in Scia Engineer 3D window, and then the result looks like this, with the information about the nodes and the elements. So we decided to improve this mesh refinement, to create some smart and automatic mesh refinement. So it's the solution of the previous problem. It's based on the mathematical concept of the finite element method. In this case, it's based on a posteriori error estimators, and the exact method is Zinkiewicz, Zhu, and some super patch recovery. We are using some books to read it and learn how it works, and we successfully implement it. The benefits for the user is that the user can use it or cannot. You can set it in settings for the mesh. It helps you to find the proper mesh much more easily and much more faster than before. You don't need to be an expert in a meshing, so you can just click on a button and it will automatically solve all the problems around. You can see and use proposed mesh refinement in the results window. You will see it on a video with the live demonstrations. You can also compare results on two meshes in engineering report, and all. So it means that the user doesn't have to think about the mesh refinement at all. So why smart mesh? It's speed of work, manual work is excluded, accuracy of mesh, results visibility, and then transparent. So I will start the video presentation. So I open the mesh setup. I click that I would like to use the elastic mesh, use automatic mesh refinement. I will set some target error, and I will select the load case for the calculation. Here I can see the quality of the mesh, and I can also select the mesh refinement. I can generate the new mesh, see how does it looks, run the calculation one against. You can maybe see that the quality is 25%. The quality, it means that the smaller number is a better. So I think I can say that the quality from 0 to 10% is very good. From 10 to 25 it's okay, and from 25 to 100 it's very poor. So you can see that it solves all problems around the support by columns. Maybe you can notice that the quality of the mesh was 19%. So each run or each iteration of the mesh refinement decrease the number, and it will produce the better quality of the mesh. I can also select the different load case than I used during the calculation, and see also the numerical error or the density of energy for the calculation, or the proposed mesh density, and here you can see the results for the internal forces, or the results for the stress strain. So this is the end of the video. So I will continue with my presentation. So the next improvement was done in geotechnics. We improved the input of geotechnical profile. Now you can easily Ctrl+C, Ctrl+V from Excel to define the pile profile or the geotechnical profile in a Scia Engineer. You can also define the geotechnical fall. It's a brand new feature in the case of the calculation with the soiling. Here I'll present you the results of the contact stress for sigma Z, and here along the geotechnical file you see the different result. I also prepared some very short and very quick video of these improvements, so you can define the geological profile, I can insert the new profile. I open my Excel, Control C, here Control V via paste all. I can rename it to the gravel pile, click on OK, and I have the new defined geological profile. I can close it, and here I have some borehole. I can attach my new geological profile as a gravel pile. Here I can define my subsoil parameters, and here I can define my parameters for geological areas and define the geological fault. Then I can run the soil-in calculation, and after the end of the calculation I can check the results. For example, the contact stress, the soil-in was finished. Here are the results of the calculation, contact stress, and you can see that here and here are different results which are caused by the fault in the geotechnical profile. So now you can model much more realistic your soil profile under your structure. So that's it from geotechnics. Another improvement to better understand your results was done in the 3D displacement. It means that you are now able to see the global deformed shape of the cross section, and you can also see the deformed shape of 1D member. You can see the rotation of the member around the x-axis, which wasn't possible in the previous versions of Scia Engineer. And you can see also the results of the calculation with the ISO lines. So the results of the free displacement as was it in previous versions, and here is how it looks like in Scia Engineer 14. The same improvement was done for 3D stresses. This is how the stresses on 1D members looks in a Scia Engineer 2014 13.1. And here is the results in a new version of Scia Engineer 14. You can see the results on the deformed structure, and you can also see it as a ISO lines or ISO bands. So the last improvement which was done for the results was the question before the deleting of the results. You can enable it in options others. So here you can see the checkbox enable question before deleting of the result. It means that when you do some change which will affect the results of the calculation, then you will see this message box that this modification will influence the results. Do you want to continue? And here you can see the message that the last calculation took 5.1 seconds. In the case of the large model or a large calculation, it can be 1-2 hours, and you can erase your results by one misclick. Therefore, we implemented this question before the deleting. So to be sure that you know what you are doing, and that it's something what you want to do, that it's not some misclick and you will lose lose time with the recalculation of the models. It can take several hours, and it can be problematic in some cases. And then the last improvement, or the last information, is related to the development of our partner panelist software, which produced the tool EC Tools, which is mainly focused on design of concrete structures according to Eurocode A, and it's according to the seismic design. They developed the version for the ACI, and you see the results of the link between the Scia Engineer 14 and EC Tools 1.5, with the two versions, one for the Eurocode and the second one for the ACI. So I think that it's all from my side, and thank you for your attention. If you will have some question, don't hesitate to send me the mail on the address which you can see here. So thank you for your attention, and I will switch the presenter back to my colleague Sonia.
Thank you, Jarde. So, last but not least, I will be giving you a sneak preview to two projects that are currently in development. In fact, already big steps have been taken in these developments, but as we aim for high quality, we are going to start a beta testing program to collect some user feedback, so we can then steer further improvements before the actual release of these two projects. So what is it about? The first project is the complete revision of the 1D reinforcement design and checks according to the Eurocode. So you see here already a screenshot of a result as it looks now in version 14.0. Okay, there we go. So in fact there are two new technologies who have made it possible for us to completely revise these design and check functions. These are on the one side the Scia design forms, and on the other side a powerful new concrete toolbox containing a set of generic functions for design and checking. So you see already that we can make use of all the advantages of the Scia design form environment. For instance, we are able to show formulas, nice pictures, interaction diagrams, and so on. So what are the highlights of the current development? So as I already told you, the generic functions have made it possible to support arbitrary cross-section shapes, including openings, and arbitrary reinforcement positions as well, and also to support the interaction of all internal forces. And the focus during this development is laid on performance, quality, and transparency. The second project that is in development is the design of composite steel and concrete floors. So here again you see a screenshot of a small project, and in the preview at the right side a detailed output of a composite beam check. So again here, as we have made use of the Scia design form environment to develop this composite beam check. The highlights of the current development are a completely new analysis model which supports 3 stages: the construction stage without concrete stiffness, the final long-term stage with reduced stiffness due to creep, and the final short-term stage with full concrete stiffness. And based on the results of these analyses, you can execute detailed composite beam checks according to the Eurocodes or according to the American AISC codes. The check also includes an automatic calculation of the effective width and the degree of shear connection. So if you are interested, during the next week you will all receive an email invitation to take attend our sneak preview webinars. The first one about reinforced concrete will take place on the 4th of June. And the second one about composite steel and concrete structures will take place on Friday the 6th of June. What will be the content of these webinars? You will get a live demonstration of the currently implemented features. So you will get to see the latest status of the development, and you will also be informed about the next steps in the development. And we will also give you an introduction into our beta testing program. So if you're interested, you will get to know what it means to be a beta tester. We will ask you, of course, to give us some feedback, and then we will also, from our side, inform you about the next steps, the next improvements based on your valued feedback. So the last slide, here you will find some contact details. If you're interested in some of the new features, for instance, if you would like to see more or to get some commercial information about the Open Design Check module, you can contact your local sales representative or send an email at the sales address, so sales@sciaonline.com. For user questions, of course, you may contact the support department. You will find here also a link to the tryout version if you're not a customer yet. And also from next week you will get access to the Scia Engineer 14.0 release website, and there you will find more information about everything that was shown here today. So if there are any other questions, you may put them to the chat box, and we will try to answer them.